All right, so section 2.3 is measures of central tendency. And so we're going to talk a little bit about different measures of central tendency. The first one being the mean, the second one will be the median, the third will be the mode. Okay, so what we have here is the definition for the mean. So it says the mean of a data set is the sum of the data entries divided by the number of entries. This is what we call the average, okay? So guys, we're going to use the term mean, but remember mean is the same thing as average. So we're going to talk about two different types of means. One is going to be the population mean, and one is going to be the sample mean. So just to give you a heads up, this little symbol here kind of looks like a U or like a slanted M. The way I read that is mu. Okay, that's mu right there. And mu is always going to be my population mean. The second one that I have here is X with a little bar on it. And because it's X with a little bar on it, we simply just call it X bar. Okay. All right, and all that info is right here. Look, pronounced mu, and X bar read as X bar. Okay, represents the sample mean. All right, so let's take a look here at a couple of issues. So it says the mean of a data set is the sum of data entries divided by the number of entries. And then we have our two formulas, okay? So one thing I want to mention is this symbol right here. This is the Greek letter pronounced sigma, and sigma means, sigma means to add, okay? So we're going to add all of our values and divide by the n is going to be the number of my population, and that'll give me my population mean mu. And to find X bar, I'm going to add whatever values I have, and I'm going to divide by the number in my sample, okay? So population mean uses the Greek letter mu, and sample mean uses the X bar, okay? And again, it has that right here. The capital N represents the number of entries in the population, while N represents the number of entries in the sample, okay? The median, it says the median of a data set is a value that lies in the middle of the data set when the data is ordered. Okay, so that's going to have here. What we mean by ordered, we're going to put them from smallest to biggest, okay? So it says the mean of a data set is a value that lies in the center of an ordered data set. If the data set has an odd number of entries, the median is the middle number. If it has an even number of entries, the median is the average of the two middle numbers in the ordered set. I'm going to go through in a couple of examples right now, okay? Let's talk about the mode, I'm sorry. The mode of a set is the data entry, that appears with the greatest frequency. All that means is which is the number that occurs the most, okay? It says a data set can have one mode, more than one mode, or no mode at all. Alrighty. So now it says the ages of samples of students in a freshman level psychology class are listed. Find the mean, the median, and the mode score. Use X bar to denote the mean. Okay, so I want you to notice something here. They're asking me, number one, to find the mean, and they're asking me to use the symbol X bar. Remember what X bar means? X bar means I'm finding the mean of a sample, okay? All right, so give me 1 second. I'm going to grab my calculator. Okay, so here's my calculator. Let me turn it on, clear all that business out of there, and let me make sure, yes, we can see everything. All right, so I'm going to start adding up my numbers. 20 plus 20 plus 20. How many 20s do I got? 1, 2, 3, 4, 5, 6. So I tell you what, why don't we do this? Why don't we say, let's take 20 times 6, okay, plus, how many 21s do we have? We have 1, 2, 3, 4, 21 times 4 plus 1, 2, 22 times 2 plus 1, 2, 3, 4, 23 times 4 plus, and then it looks like we got a 65. Okay, there we go, equals. So my sum is going to give me the numbers 405. Okay, so right here, the first thing I'm going to do, what is my sum? 405. Okay. The next part is, what is my n? So if I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's a total of 20 students, right? So n is my 20. So then my x bar would be, what's 405 divided by 20, right? Okay. So if I grab my calculator again, let's just divide that by 20, and we're coming up with 20.25, okay? So my average is 20.25 years. That is the average age of the students in the class, okay? Now, we're going to find the median. So remember what the median is. The median is going to be our middle value, right? So it's going to be our middle value. So remember, we had a total of 20 entries here. So that means I have an even number of entries. So there's not exactly one number in the middle, but the middle number, or the median value, would be the average between those two. Because if I put all the numbers already in order, the middle two would be 21 and 22. So we're going to say, let's take 21, let's add 22, we're going to divide them by 2. That's going to give me 43 divided by 2. So if I grab my calculator again, what is 43 divided by 2? Pop, 21 and a half. So my median is 21.5, okay? There's my median. All right, then the next thing we want to find is, which is the mode. So what was the number that occurred the most often, right? The most often. It looks like the number that we had the most often was 20, right? Because we had 6 20s, we had 4 21s, we had 3 22s, we had 1, 2, 3, 4 23s, so on and so forth, right? So the number that occurred the most often was 20. Okay. All right. So it says, although each measure describes a typical entry, each has its advantages and disadvantages. The mean is reliable as long as it takes all values into account. However, it can be greatly affected by an outlier. In the example above, the median is best described the data set because of the outlier. So what we mean by the outlier, guys, is when I look at my numbers that I had here. So let me get my highlighter. I'll tell you what, let me erase this. Okay. And let's go with yellow. Okay. So what we mean here by the outlier, if you look at the ages, 20, 21, 22, 23, 24, boom, 65, right? That's what we call the outlier. One of those numbers is very different from all the others, okay? So when we have an outlier, what we say is the median is always going to be the best representative of the data set, okay? All right. So it says an outlier right here is a data entry that is far removed from the other entries in the data set. Okay, so now it says find the median in the mode and label any outliers. Okay, so we're going to find our median, and I'm going to show you how to do this on your TI calculator, okay? So on your TI calculator, you're going to have a button that says stat, yes. And then we're going to have a, number 1 says edit. So we're going to edit. I can just hit enter. And if you notice, my list here is complete. It's empty, right? There's nothing there. If your list wasn't empty, you could just do the little up arrow to where you're highlighting the L1 and hit clear, and it'll clear everything out, okay? So, mine was already clear, but if you do that, it'll clear it out. And so what I'm going to do, remember how I'm going to read these numbers over here? That's 16 and 19. So the first number is 16. Enter. Oops. Let me see. Stat, edit. Okay, 16. And then, there we go. I had to hit down arrow. Sorry, not enter. 19 for the second one. 24. 25. 33. And another 33. And two 34s. 1 and 2. And two 37s. 1 and 2. Okay. And then we have a 40 and a 42. And it looks like we got three 46s. That's 1. That's 2. That's 3. And we have a 49. And then I want you to notice the next number in the list. The next number in the list, because there's nothing here in the 50s or the 60s, then the next number we have is 73. Okay. Boom. Okay. So now that I've done that, I'm going to come back. I'm going to hit my button stat again. And I'm going to go to calculation, which is the second one. And I'm going to hit one variable stats. I'm already on the number 1. You can either hit the number 1 or you can just hit enter. Okay. And I'll hit enter again. Okay. So now it's asking me to find a couple of things. Remember what we're looking for? We're looking for the median and we're looking for the mode. Okay, so remember the median. Remember the symbol we use? I'm sorry, we're looking for the median and the mode. I'll tell you what, let's find the mean anyway. I know I didn't say it here, but let's find the mean. Remember what we call the mean? We call the mean x bar, right? So if I come back to my calculator, look at what my x bar is. It's 37.294. I'm going to try to be as consistent as possible, and for the most part, I'm going to try going to 3 decimal places, okay? So if you notice the number to the right of the 4, it's a 1, so I don't need to round that 4 up. I'll just write 37.294. So right here, I'm going to write 37.294. Okay. Then we're going to look for our median, okay? The way we can find our median, remember our median is going to be the number that's directly in the middle, right? Okay, so I'm going to scroll down here. Do you see right here where it says MED? That is my median. It's the number 37. Okay. And then remember how we find the mode, right? The mode is the number that occurred the most often. So if I look at my list, right, what was the number that occurred the most often? Well, I noticed I had two 33s, two 34s, two 37s. But we had three 46s, right? And that's going to be my mode. Okay, so we got the median, we got the mean, and we have our mode. Okay. So let's take a look-see at the next part here. And we're talking about weighted means. So it says sometimes entries in a data set have different weights. In such cases, weighted means are calculated. It says a weighted mean is the mean of the data set whose entries have varying weights. The formula is given by, and it gives me this formula right here. Okay, so x bar equals, again, remember what this is? This is sigma. And remember what sigma means? I keep forgetting how to spell the word add. Aren't you glad I don't teach English? Add. Okay, so sigma means to add. Okay, so we're going to add each of the entries times their weight, and then we're going to divide by the sum of the weights. Okay, so let's take a look at what it says here. It says Jessie is in Math 1442, where her test average counts for 40% of her overall test grade. Her midterm counts for 20%, and her final exam counts for 25%. Also, her homework counts for 15% of her overall grade. Okay, so let's go slowly. What do we know here? It says her test average is 40% of the grade. So right here under the test average, as a decimal, 40% would be 0.40, right? It says the midterm is 20%. So right here under the midterm, I'm going to put a 0.20. Okay. The final exam is 25%, so the final exam is going to be 0.25. And let's see, the homework is 15%, so that's going to be 0.15. If you notice, when we add all these numbers up, guys, we end up with the number 1. Why 1? 1 is the same thing as 100%. Okay. So now let's see if we can fill in the other pieces of information. It says she scored an 87 on her midterm. So right here under the midterm, I'm going to write the number 87. Okay. She had a 92 average on her test. So under the test average, I'm going to put a 92. 76 for her final exam, and an 85 for her homework. Okay. Now, I want you to notice the third column. The third column says we're going to take the x values. We're going to take each of these numbers here, and we are going to multiply them by each of the numbers here. Okay. So let me grab my calculator again. Let me clear that out. And I'm just going to multiply 92 times 0.40. Okay, 36.8. So right here, I'm going to put, let's write this in black, 36.8. Okay, and grab my calculator again. Where is it? Here we go. Okay, 87, let me see, 87 times 0.20, 17.4, 76 times 0.25, oops, 25, and there we go, 19, and then 85 times 0.15, 85 times 0.15, 12.75. Okay, again, remember what that symbol is? Sigma. Let's see if I can write it this time correctly. To add. Okay, so now I'm going to grab my calculator one more time, and I'm going to add each of those numbers up. 36.8 plus 17.4 plus 19 plus 12.75. And 85.95 is the average. Okay. One thing I want to mention, a lot of times students ask, should I do any rounding? Remember when we did our calculation earlier over here, for the most part, I will round to like 3 decimal places, right? If I have less than 3 decimal places, I'm not going to round this up to an 86. I'll just leave it as it is, okay? So just wanted to give you all a heads up on that. Okay, it says, for a data that's represented in a frequency distribution, we can approximate the mean by using the formula. It says the mean of a frequency distribution for a sample is approximated by x bar equals the sum of x times f divided by the sum of f. And it says, remember, the sum of f is the number of entries that we have. It says where x and f are the midpoints and frequency of each class, respectively. Okay, so let's take a look at the example here. And it says, the table below shows the length of 50 pieces of wire used in a physics laboratory. Approximate the mean of the frequency distribution and round your answer to the nearest tenth. Okay, so in this particular problem, the problem is very specific. It's telling me to round to the nearest tenth. Just in case you forgot, that just means we want to have 1 decimal point, okay? Okay, so in doing this problem here, I want you to think about what we have. We have pieces of wire, right? We got pieces of wire here. So the first sort of class that we have 1, 2, 3, 4, we have 5 classes, right? Okay, so in the first class, we have wires of lengths between 26 and 30 millimeters, right? How many do we have? We have 4 of those. I don't know if those 4 pieces are all 26. Could some of them be 27 or 28 or 29 or 30? Yeah, they could be any of those, but I don't know. I know there's 4 pieces total, but I don't know the individual measurements of each of those 4 pieces. So this is what we talk about. We're going to approximate the mean, okay? We're going to find the midpoint. Remember how we find the midpoint? We're going to find the middle between those two. So the way I find the middle between those two is I say, let's take 26 plus 30. We're going to divide them by 2. That's going to give me 56, and I'm going to divide it by 2, and that would be 28, okay? That's going to be my midpoint. And I can do the same thing for the next one, right? So I can say, look, 31 plus 35, that's my second class, right? Oops, what happened to my pen? There we go. Let's take them together and divide by 2. That's going to be, what, 66? And if we divide it by 2, that's going to be, what, 33? Okay. Guys, remember when we did this the last time? We can say, how much did we move from 28 to 33? We went up by 5. So wouldn't this one here be 38? And if we add another 5, 43. And if we add another 5, 48. Okay. And then if you notice, what we're going to do now is we're going to multiply. So I'm going to take my calculator again. Let me move it this way now. Okay. Clear it out. So we're going to go, what's 4 times 28? Okay. 4 times 28 is 112. Okay. 10 times 33, I can do that one in my head, 330. Okay. I'm not that good. I can't do 12 times 38 in my head, so let's do it here. 12 times 38 is 456. Alrighty. 18 times 43, 774. And 6 times 48, quien sabe, let's do it here, is 288. Okay, now, a couple things we need to do. First thing we got to do, we got to find that sum. Okay, so let me grab my calculator again, and we're going to take 112 plus 330 plus 456 plus 774 plus 288. Okay, and that's giving me 1960 right here. Okay, the other thing we need to do is we need to find the sum of F. How many pieces of wire do we have? I don't know. Let's add them up. 4 plus 10 plus 12 plus 18 plus 6 is 50. Okay, so now the way we find our X bar is we're going to take 1960 and divide it by 50. Okay, so 1960 divided by 50, okay, 39.2. Remember what it told us earlier in the original problem? Let me scroll back up, round to the nearest tenth, and we said that tenth means we want to have exactly 1 decimal point, and we did. And so there is our average, right? We found the mean of the frequency distribution. The average piece here was 39.2 millimeters, okay? All right. Okay, so under shapes of distributions, we have something called a frequency distribution is symmetric. What we mean by symmetric is we can draw a line cutting it right in half, right? It's like this line is like a mirror. What this shape here is the same as that shape over there, okay? So what you see on one side, you see on the other, okay? And that's why we say a vertical line can be drawn through the middle of the graph, okay? And it says, the next part is uniform. So it says when all entries or classes of the distribution have equal or approximately equal frequencies. This is what we call uniform. I want you to notice this is also symmetric because this side here looks just like that side there, okay? And then we had what we call skewed left. Okay, skewed left, guys, means if I draw a curve, kind of doing this number here, this is what we call the tail, right? Because it's kind of flattens out more. The tail goes to the left. And then we have something that we call skewed right. And if you notice, the tail kind of goes to the right over here, okay? So there's a little bit of information about that. I'm going to kind of hold off on that. We'll get into that a little bit later, okay?